Hello again. It's another SAP Tech Bytes video with me, Marius Obert. In one of the last videos, this one, I showed you how to create multi-module SAP Fiori projects that only contain UI modules that don't consume any runtime resources on SAP BTP. Essentially, these projects just provisioned a few service instances of the destination service, the Access UAA service, and the HTML5 app repo service to wire everything together. And as SAP BTP has the concept of environments, we needed to pick an environment where these service instances can live. And for that, we picked the Cloud Foundry environment. In this video now, we'll do a similar thing, but use the Kyma environment. If you have both environments at your disposal, and you don't want to implement a backend component, it really doesn't matter much which environment you pick. But this changes if, let's say, you have a Kyma component running as part of the project anyway. In that case, it absolutely makes sense to create the service instances for the web app in the Kyma environment as well. And that's what we do now. We'll build and deploy a small project that consists of a backend component and the SAP Fiori application and deploy it to SAP BTP Kyma Runtime. Okay, let's get started to deploy a SAP Fiori application via the Kyma Runtime to SAP BTP. What you see here is the Kyma console, and I already mentioned briefly, in order to complete a task for today, we need a destination service, an authentication service, and the HTML5 application repo service. To do that, or to get started, let's have a look at the catalog to see if we have all services that we need. So here on the left-hand side in Service Management, you can select Catalog and just search for the ones that you need. Destination service, okay, we got this one. HTML5 application repository looks good as well. And here's the authorization and trust management service, also known as Access UAA. So I think we have everything to get started. So let's switch over to an empty project in VS Code. And you see there are no files there yet. So let's change that. What we want to build is, I already mentioned briefly, an application or a project that consists of two microservices. One is a backend service that just decodes the JOT token that comes from the Access UAA service. And the second one is our web application. Let's start with the backend. So let's create a folder called backend, and it has a backend.js file. And yeah, let's copy the value over and then let's discuss what happens there. Okay, so here you see this is a very tiny application that uses the express package and the JOT decode package to decode the JOT token. We start an express server and we listen on the root just to make sure to give us an indication that the application is running. And then we return a success message here. And this is where the actual magic happens. So when there's a request coming to the /token endpoint, we basically log this request and then we check is the user authenticated. If not, return this message. And if the user is authenticated, just return the decoded token. Okay, that's all that we need. Obviously, as this is a Node.js application, we also need a package.json file. Let's also copy that over from here. This is all pretty standard. We reference the start script, we give a name and a version, and we declare the dependencies, express and JOT decode. And that's all that our backend microservice consists of. Okay, so let's jump to the second application. And this is the application that uploads our static resources to the HTML5 application repository. For that, we create a second folder here. Let's call it deployer, as this is the deployer module. And in the deployer module, there should be a resources folder for all web applications and one specifically for our web application. As we only have one, we only need one subfolder here. And for that, let me also once again copy the files that we need over here. You see there is an index.html page, which is the typical entry point of a web application. So here we define some meta tags, and we bootstrap the UI5 library, and then we just define the entire web application in this index file. So there is an application with one page. That page has a button and to log the user out, and a generic tile, and that tile basically sends a request to, where is that here? Oh yeah, it sends a request to this token URL that we defined in the backend service previously. Besides that, we have the logout page that just tells the user you are now logged out. Click here to return to the application where the user could click to log in again. And we got a manifest.json, which just contains some basic properties of our application, such as the application ID, token display, and the business service that has the name business.service that we need for the managed app router later on when we deploy the application. So let's have a look at this application as is, and let's start it locally. For that, I am already in the folder. So when I do ls here, I see all the files. And what I usually do is I use this HTTP server. This is a globally installed Node package just to start a web server locally that exposes these files. So when I click here, you see this is how the application looks. So when I say fetch data, I get an error message now because the backend service is not connected here. And so that's expected, but we see the web application is running, and I could click log out, and I also get an error message here because this is just static content running. It's not running within the app router. So let's change that, switch back to our code. And because in order to make this web application runnable within the managed app router, we need to add one more file, that access app.json file that defines the routes, the path to the logout page, and the logout endpoint, for example. So let's create one new file here, same directory as the index.html page. So let's paste content in here. We see this is mostly standard code. So the welcome file points to the index.html page. The authentication method is route. So we want to make sure all routes are authenticated so that the user has to be logged in, with one exception that we see in a second. And this is the logout endpoint. And once the user is logged out, he or she should be redirected to logout page.html. So there are three routes. The first one I think is pretty clear. If the user requests /token, the traffic should be redirected to the token service. This is the backend application that we defined here. And obviously we need access UAA here. Actually, we wouldn't need to declare that line as we already defined it up here. The second route points to the logout page because for that page, obviously, the user doesn't need to be logged in, because if the user logged out, he or she doesn't have a valid token. So obviously this needs to be a public URL, but for all the other resources, which is in this case only the manifest.json and the index file, for that the user has to be logged in, and the traffic will be redirected to the HTML5 application repository runtime service. Okay, so up to here, this is all pretty standard. It's just pure Node.js. It has no dependencies to Cloud Foundry, to Kyma, to Kubernetes whatsoever. It's just the pure code that describes what we want to do. So in the next step, let's add Docker files in order to Dockerize these services into containers and images and to upload them. So we paste the Docker file in here that I prepared. You see this is a pretty standard Docker file that you could use for any Node.js application actually. So it is based on Node version 14, the Alpine version, which has a very small footprint. we declare this app directory, copy all files over there, execute npm install production, and expose port 5000 here. And then we just call npm start. And actually, we could use the very same image also for this deployer application here. And now I remember that I forgot one file here because I forgot the package.json of the deployer. So let's add that quickly here and take the content. But this is also a pretty standard procedure here. It's just this, it says one dependency, and the start script basically executes this dependency, which will then take the content of the resources folder and upload it. Okay, so I already mentioned that we can use the same Docker file in here. Technically, we don't need to expose a port because there's just outgoing traffic from this container to upload the resources to the HTML5 application repository, but there's no traffic incoming. You could expose this port, it doesn't matter. So, but let's remove that for now here. And then one more file is needed, especially if you are running on a Mac, because you can, similar as a git ignore file, you can have a docker ignore file as well. And this docker ignore file should put this ds store file that the Mac operating system creates automatically on the list, because you don't want that these files that might live in the web app are uploaded to the HTML5 application repository. So this is basically a safety net for you. And yeah, make sure it's in the deployer folder here. And that's all we have to do to prepare, basically. So let's go to the deployer folder here and start Docker build to build a Docker image based on the description of the Docker file. To do this, really simple, you just need to have Docker installed and run docker build, define a tag name, and I choose this tag because what you see here is the username that I have on Docker Hub, and then I define the name of the image. This is useful later when I want to upload the image to Docker Hub, which I'll do in the next step. Okay, so this is the name of the Docker image that I want to use, and then I just add a dot because the Docker file lives in the current directory that I'm in. Now the process starts. For the deployer, it will be really fast because it only has one dependency and only 4 files in the web app folder. So you see live what is happening and that it finished. So let's now push this image with docker push, and then we use the tag name that we assigned in the previous command. And also this should go really fast. You see it's just a few megabytes that are uploaded. Most layer already exist on Docker Hub because this is the base image that we are reusing here. And a few moments later, we get a success message. Perfect. So let's do the same steps also in the other directory where our backend application lives. Same command, docker build -t for our tag, and here we call this one just simple backend, start the build. Also, this was even faster than the previous command, and push this image also. And you see, basically done. Awesome. And now we basically already built and prepared the images in the Docker registry that is now Docker Hub. And the next thing that we need to do is basically provide the construction, the recipe for Kyma, if you want, in this project manifest that explains how these Docker images should be used to build our overall project. To do that, you might know the the MTA.yaml file from Cloud Foundry, and for Kyma or Kubernetes, there is a similar construct that most often is called deployment.yaml. You could also call it manifest.yaml. The file name actually doesn't matter much. Okay, so this is the content of the file. Let's inspect that section by section, or how you call it in YAML, document by document. And each document is separated with these 3 dashes from other documents. Let's go to the bottom. And here we see 3 service instances, 1, 2, 3, and 3 service bindings, also 1, 2, 3. And you can already guess what this means. So let's have a look at the first service instance. Basically, this is the definition of our Access UAA service. And you probably also know these parameters when you developed on Cloud Foundry before, because these parameters are usually stored in the access security.json file or also in the mta.yaml file. And here we define them inline as well. So we define an app name, we say that what a tenant mode is, and some OAuth2 configuration parameters that we don't have to discuss in detail here. And similar, the second service instance is the HTML5 apps repo host service. And the last service instance is our destination service with the service plan light. And also be aware that the parameter HTML5 runtime enabled has to be set to true, and there has to be a version in here. Okay, so basically now the source instances are defined, but we need to make sure we can bind them to our running Docker images, so-called Docker containers. So for that, we use the kind service binding, and basically in the service binding, we just reference the name of the service instance. So here we basically, in the metadata of each service instance, we assign the name, and the service binding just references this name. And in the metadata, it has its own name. So the binding has a name, and it references the name of the instance. And this pattern is the same for all source bindings that you see here. So there's nothing special. And besides that, let's maybe go to the top and have a look at this deployment here. So this is the deployment of our deployer application. And in the spec section, we say we need 1 replica. Template should be based on this Docker container that we defined here. This is the same name as we used previously. The image should always be pulled on each deployment, so it shouldn't cache it. For production, it would obviously make sense to cache it, but here it's okay to pull it every single time. And then we mount volumes. Let's go over this for a second, and let's have a look at the volumes. So here you say each volume has a name, and it has a secret, and the secret is the name of the binding. So here we basically say the deployer application should be bound to the HTML5 host service, should be bound to the Access UAA service, and should be bound to the destination service. Right. So in the first step, we define the volume, and here in this step, we mount the volumes. And we actually mount them to a very specific path so that our application can find it. And basically, with these 4 steps, step 1, definition of the service instance, step 2, definition of the service binding, step 3, usage of the service binding to define a volume, and step 4, mount the volume to a mount path. With these 4 steps, we are able to create a service binding in the Kubernetes environment or Kubernetes runtime. Okay, and besides that, we have some environment variables that define the business service. So here you need to make sure that you use the same service as you used in the manifest.json of the web application. And you also have to declare the destination that points to the destination, to the token service. And for that, you need to adjust this URL. Basically, you need to add your domain identifier of your Kyma cluster in here. So in my case, it's this C-1309 and so on. You can find your domain identifier when you go to the Kyma console and you have a look at the URL. So this is your domain identifier. Okay, back to the code. You see that this is everything that we had to define for the HTML5 app deployer. So let's collapse that again. And let's jump on top to the first deployment that follows a similar pattern. So one replica is enough here as well. For the template, we use this container that we previously created as well. Once again, we always pull the Docker image, we give it a name. And here we do a binding as well. So here we see that we mount only the XSUA service because that's the only service that we actually need here. And obviously, to mount the volume, we have to define it here. For that, we could reuse the same service binding. So we don't need to create a second service binding here, which makes it a little bit easier if you want to bind one service instance to multiple Docker pods. And we also define an environment variable here, but let's actually remove that because we don't need it, because the standard port of our backend is 5000 anyway. But if you want to choose another port, you could define it in the environment variable as you've seen it, and then that value would be chosen instead of port 5000. Okay, so this is a little bit easier to understand, this deployment here. Let's collapse it again. But this time, there's one or two more steps that we need actually to make our backend service available on the internet. We need to, because so far it's the Docker image exposes a port, but Kyma doesn't expose that port. So for that, we need to define a service that basically says expose a port on a Kyma node and expose port number 5000 of our application backend. So this is basically the label that we refer to up here. So this basically sets the relation between the YAML documents in this file. And now we define the service, but we could use the service for internal communication, but we actually also want to expose this externally outside of the Kyma cluster. And for that, we need one more definition, this API rule that basically has a dependency on the service. Let's have a look on the service backend service, what we use here on port 5000. And here we basically say forward all traffic, so allow only get and post, and put no authentication restrictions in front of that API rule. So basically everyone can call any URL of the backend using HTTP method get and post. And this is basically the entire content of this deployment YAML file. Let's collapse all of this again to go over the single documents one by one in a short recap. So first, this is the deployment description of the backend service that is using the service binding to the XSUAA service and exposing internally port 5000. Here, we basically declare that this port should be provided as a service within the Kyma cluster, and the API rule makes this service accessible from the internet. The second deployment is our HTML5 deployer application that has a binding to the XSUAA service, to the destination service, and the HTML app repo service of service plan host. And here we have the service instances and the service bindings as we previously discussed. Okay, so much for the theory. Let's deploy this to see it in action. Here, let's first use kubectl and define the namespace that is called SAP Tech Bytes here. Oops. And say get pods to see that actually there are currently no pods in this namespace. no resources found in SAP TechBytes namespace. Let's change that and let's deploy our entire project based on this deployment.yaml file. So to do that, we just use apply -f to deploy to the file to reference the deployment file. Oh, I'm in the wrong directory. Yep. So enter the command again. And now you see what, based on the documents here, various resources have been created. So it created, for example, this service here. This created 2 deployments, 1 API rule, a few service instances, and service bindings. And now if we execute our get pods command again, we see that basically 2 pods already started and 1 is still initializing. And let's switch over to the Kyma console to see basically the same information here in the UI. So let's go to overview. Here you see, okay, there are 3 deployments and 3 pods currently started. All the pods are running and they didn't restart so far, which is good, because if they restarted, it basically means they crashed the first time they tried to start. And if we go to services, we see our backend service here. And if we go to API rules, we see the API rules. So let's have a look at that first. And we see a success message. So we already see that our web application is running here. And now there is also this. Let's have a look at this /token endpoint. And this is also what we would expect. We get a no token found message because I'm currently not logged in. I just accessed this URL directly. Okay, for the next step, let's jump over to the BTP cockpit and refresh it here. And now we should see our web application here as it's already deployed. And then we could use the link here. So this is our web application, token display, and it's of the business solution, business service. Let's click on it to see our web application in the cloud made available through the managed app router. So this is the app that we know. And this time when I click fetch data, I actually see the data from the UAA, from the JOT token that is returned from the UAA service. For example, I see my name here and other information. The second thing that we could try is to use the logout button. We get to the logout page and then we can say return to the application if we want to log in again, for example. Okay, that's it. I hope you were able to code along and to make your SAP Fiori application running on SAP BTP via the Kyma Runtime. And even more important, I hope you understood everything that I showed you. I know it can be a little bit complicated, especially when we dive into this deployment.yaml file, as YAML files are maybe not the easiest files to read. They are very long and they might contain constructs and directives that you are not yet familiar with. For that, I can tell you, everyone starts at this point. Don't give up, just keep on learning and try to find, like, maybe start with YAML documents that you know, that you understand from, for example, Cloud Foundry, and then start with this as an anchor point and look at the references. Where is this tag, or where's the metadata used of this YAML document? How do these parts belong together? And soon you'll be able to read the entire file from top to the bottom. And then I think you will also see how much more flexibility Kyma and Kubernetes is able to offer compared to Cloud Foundry, whereas Cloud Foundry is very helpful if you want to get started soon and you're happy with the default settings and you don't want to customize many things. And Kyma then comes in the game when you say you want to go beyond this default configuration, when you want to have more flexibility and more freedom. Okay, I hope this helped you and see you next time.